Welcome to the physics test review. This is Miss Wimwehen, and I hope that this helps you prepare better for your physics exam or either clear some misconceptions you had. So the first question, it asks you about the unit or the instrument used to measure force. That is the spring scale. And what that is it's a scale that has a spring inside of it. And you pull down on it, and where you've seen this is probably at the grocery store when you weigh your apples and bananas and other fruits and vegetables, and you put that in, and then the dial moves around because the spring is getting stretched out, and that measures force, and it also measures weight, not mass, but weight. The unit for force is the Newton, after Sir Isaac Newton. A change in motion is caused by an unbalanced force. Now that can cause something to either stop moving or to start moving. So if you are driving in your car, to think about what stops you when your parents might have to slam on the brakes. That's a seat belt. So that seat belt helps you overcome inertia, because inertia says that it wants you to keep moving, but the seat belt, thank goodness, helps you to stop. In order to get you to start moving, somebody might push you. That push would be the unbalanced force. Energy in motion is kinetic energy. Energy at rest or stored energy is potential energy. The force between objects that affects how easily they move past each other is friction. That's not to be confused with inertia. So when you think friction, think of something like the rubber on the bottom of your tennis shoes. That adds friction so that you don't slip and slide everywhere. The force that pulls object together, that is gravity. The amount of matter in an object, mass. The strength of an object or event, that is its magnitude. A push or a pull, that's force. The tendency of an object to resist a change in motion, we just talked about that, is inertia. The more mass something has, the more inertia it has. So an 18-wheeler has a lot more inertia than a Honda Accord or a small sports car because it has more mass. So it is harder for it to overcome inertia. It's harder for it to stop, or it's harder for it to start moving if it has more inertia. The sum of all the forces acting on an object is its net force. Net means total. Net means total. If a force pulls an object north and another pulls south, what kind of math would you use? So what it's asking here is if this is going this way and this is going this way, what do? You subtract. So what kind of math would you use? You would use subtraction. You are pushing a sled. A friend is pulling it in the same direction. So you're pushing it and a friend is pulling it in the same direction. What math? You would use addition. You would add that together. The arrows are going the same way, so those forces are complementing each other. You would add them. How do you calculate speed? Well, let's draw back to our triangle. Distance is time times speed. Distance divided by time is speed. And time is equal to distance divided by speed. So between here and here you multiply, and this line tells you to divide. A trick to do that is when you're using it, you can just cover up what you're trying to solve for, and it will give you the answer. So for speed, it will be distance divided by time. How are speed and velocity different? Well, speed is how fast something goes, or it's a measure of distance over time, like we just said. And velocity is just that, but it also includes direction. So for example, 10 meters per second south, 10 meters per second north would be velocity, right? Speed would just be 10 meters per second. A car travels 50 kilometers in 40 minutes. what is the speed of the car? Okay, so what you have to do here is you have to divide. So you have 50 kilometers in 40 minutes. And I'm going to be nice and not make you convert, but it should usually be in meters per second. So this is our distance, and you always label, and this is our time. So we know from this triangle that distance divided by time will give us speed. But we're going to write down the formula and not do it on our head so that we can make sure that we make fewer mistakes. We can cancel out our zeros when we divide because that will make the division much more simple. So we put 4 into 5. It goes in 1 time. And then it goes in another 0.25 times, right? So your answer to this would be 1.25, and our units are kilometers per minute. All right, calculate each of the following speeds. What's the greatest and what's the fastest? Or sorry, which is the greatest or the fastest? So the fastest is the greatest. So if you're confused about that, think about when you're going a certain speed in a car. The bigger that number is, the faster you're going. So if you're looking for the fastest speed, you're thinking, this is how much distance I traveled in a certain amount of time. So of course you want that to be greater, okay? So what you would do here is you would take all of these and you would solve for them, okay? So speed equals distance divided by time. So you would have, for letter A, you would have 10 divided by 8. For letter B, you would have 12 divided by 9. For letter C, you would have 14 divided by 12. And for letter D, you would have 15 divided by 14. This is going to give you 1.25 kilometers per minute. This is going to give you 1.3 repeating kilometers per minute. This is going to give you 1.2 kilometers per minute. And this is going to give you 1.07. So the biggest number you would have would be 12 divided by 9, which is B. Now I didn't work out the long division for you, but I want to remind everyone that you cannot use a calculator on your end of year exam, also what we call the STAR exam. Therefore, your teachers are encouraging you or not allowing you to use a calculator in science, even though you can use them in math, because math has different rules on that exam. So while we care about you getting the correct answer, we also care more about you finding it like you're supposed to. So you do need to practice your long division. Number 11, you're on a bus that is moving 40. Actually, we are going to skip this one. Skip that one, okay? And on the test, you'll skip that one too. If you did it, then it will not count against you. Next page. A wind-up toy is released across the table. It moves at a rate of 0.8 meters per second squared. It has a mass of 1 kilogram. All right, so let's back up. That's its acceleration. This is its mass. What is the force exerted by the car as it moves. Use the formula, force equals mass times acceleration. Even better, use this triangle and use the same principles I taught you before. When you're solving for acceleration, you divide force divided by mass, force divided by acceleration, and force, mass times acceleration. Okay? So, what you're going to do to find force is you would take mass, which is 1 kilogram, times 0.8 meters per second, which is the acceleration, and that's going to give you 0.8 newtons. Okay? An athlete runs a 100-meter race, so this is its distance, in 8 seconds, which is its time. What is its acceleration from the start of the race to the finish? Now this is pretty advanced, okay? So this one,